The ground we stand on accounts for only 30% of the Earth's surface. So what about the rest? Well, that other 70% is our world ocean, which to many of us land dwellers may seem like a foreign concept. An intangible body of water largely separated from our day-to-day lives. But in reality, the ocean is the one common link that connects us all. The food we eat, the air we breathe, the storms we ride, and the economies we build are all dependent on our world ocean. On this podcast, we will dive into emerging markets, innovative technology, and conservation efforts to shed light on the ocean, the other 70%, that enables us to have a footprint, a home, and a life on Earth. The other 70% is brought to you by Nortec. As ocean enthusiasts, researchers, and technologists, we are on a mission to make an impact through innovation, exploration, and activism above and below the surface. Help keep us exploring by subscribing on your podcast platform of choice. Hello to everyone out there listening. I am your host, Nevin DeParlo, and on this episode of The Other 70%, we will hear from Nicolaus Radford, co-founder and CEO of Houston Mechatronics. As an innovative ocean technology company, Houston Mechatronics aims to change the way we view working in the ocean while building game-changing subsea robots. After spending more than a decade at NASA, Nick recognized that despite being an equally challenging and unexplored frontier as outer space, the ocean largely gets painted as an old-fashioned, beat-down place, and that ocean technology often matches that description too. And it is now his mission to change this narrative. Houston Mechatronics is pushing the envelope in subsea robotics and working hard to change the way we view ocean technology, the blue economy, and the way we interact with the ocean. Without further ado, let's dive into today's show with Nick. Welcome to The Other 70%. It's good to have you here.
Oh, it's fantastic to be here. Thanks for thinking of us, and looking forward to sharing a little bit about what we're doing.
Yeah, absolutely. And just to kind of start things off and maybe fill in some of the people listening, can you just give us, a quick elevator pitch on Houston Mechatronics and what the technology is that you guys are developing and really what the high level applications are?
For sure. So elevator, maybe coming down from the 100th floor or like the 20th floor.
We'll go with the 100th floor. We'll give you some more time.
Good. There we go. Give me some breathing room.
Yeah.
Well, HMI is a marine robotics company, and we've been at this for a number of different years, but we think that the tried and true status quo of working in the ocean is dead. And I guess I can't say it any different than that. I guess I feel saddened a little bit because other industries they get the benefit of really quick turn, easy to innovate in, low cost of innovation, and maybe space is an exception, but we found a way to overcome that with sort of public enthusiasm. But the ocean community is this ill-served, or rather underserved environment that needs it the most. And so we recognized at HMI that what we had done in spaceflight robotics, the core group of our company came from NASA, was extraordinarily apropos to what we thought the industry needed to change toward, which was a more flexible, much more lower cost, and environmentally aware way of doing work in the ocean. So we've built an entire vision, we've built an entire company around it, and we think that there's a lot of change space. There's a lot of room for the adoption of new technology if you are able to crack the nut of I don't know how to put it, but it's an unforgiving place. It's also an unforgiving marketplace. I'm learning, and so, that's the essence of who we are. We're just these. We deploy tenacious tenacity. We know we have the right solution, and we are we just refuse to give up until it gets adopted. But, so what are we doing really? There's an extraordinarily amount of legacy hydraulic infrastructure that is extraordinarily expensive to operate. It's incredibly archaic. Imagine writing an app for a rotary phone. That's what I tell people all the time. You just can't do it, right? You can't write an app for a rotary phone, and half your audience doesn't even know what a rotary phone even is. And so they think that floppy disk save icon on your computer is looks like more like an envelope or something to them. I don't know, but we feel that we can completely replace an entire industry's infrastructure of how they do work underwater.
Right.
Probably on the 60th floor right now, so I could keep going.
Yeah, no, that's a good start. Great start. We still have 60 floors left to go, so we have plenty of time to dive into some more of the details. And just to give some more background too, I mean, the way that you talk about sort of the current, I guess, industry setup and how it revolves around existing technology offshore is that there are large vessels that service, offshore oil fields or wind farms, or obviously there are defense applications as well. And then on board those vessels, you have a number of people who are actually operating things like work-class ROVs or AUVs, so remotely operated or autonomous underwater vehicles that go down and complete tasks underwater, right? So your vision is essentially to cut out a lot of the moving parts in that whole process with one system that can operate more or less from shore and eliminate people going offshore, right?
Yeah. So I should hire you, because that was a much better way to say what I would. But that's exactly right. And there's obviously a lot of emphasis on data collection in the ocean. People have been doing it for a long time. But it turns out that all of that's usually in preparation for or some greater understanding of what you're trying to actually do. And I think people really forget that this is a physical world. I mean, this is where I really gain a lot of inspiration. I'm such an industrialist at heart. I love building stuff because it's all toward the application of doing something. I mean, there's only so much data you can flow around, but at the end of the day, it's to inform a decision. Well, that decision is usually to take an action. So what I'm trying to do is just, as much as we have this ubiquity of information sharing and the manipulation of the virtual world, I believe that through the oncoming revolution of artificial intelligence and machine learning, properly attaching that to physical devices is going to be the next wave. And I think that the best value proposition for something like that would be in a hard to get place like the ocean. And so where do we need the most intelligence deployed? It's in the ocean. It's the hardest, it's one of the hardest environments to operate in. And therefore you would put an extraordinarily high premium on the intelligence in the ocean. So our company is a full stack, top to bottom. We have the hardware, we have the software. I get a lot of crap sometimes for being a very hardware oriented company, which I find extremely weird, because I employ more software engineers than I do anything else, right? A lot of my work in the defense community has to do around how intelligent we are making these devices, not the fact that it's a big orange robot, which we call the happiest robot in the ocean. But my passion lies in that I just refuse to accept that you need all this laden topside heavy infrastructure to do work underwater. I just refuse to accept that.
Right. And so as a newcomer to the space, right, obviously we've been working and companies have been working offshore for a very long time. And I'm sure you found that many of those companies are somewhat hesitant to change and from what they're used to working with and have adopted over the last number of decades. Have you seen, any pushback from some of those operators, despite the fact that, from a value add, your systems could save them? I mean, tens, if not hundreds of millions of dollars over a course of numbers of years from reducing topside infrastructure?
Yeah, pushback is a nice way to put it. The industry, and for good reasons. Let's not get too critical of the industry. The industry is very
Right.
risk averse. It's very slow to change because they deal with multi-billion-dollar installations that one wrong move and you have an environmental catastrophe. So rightly so, they're very hesitant to anything that uh, purports to save them, some money, right? And so good for them that they have an emphasis higher than money, and it's much more on reliability and the quality of the job being done. However, um, uh, we have to meet them where they're at. And so where you meet them where they're at is that you show the value prop of your technology in adjacent industries. That's why we have worked not directly in oil and gas initially, because they're a sort of a doubting Thomas, right? We'll believe it when we see it,
Right.
and that's okay. Like I said, so we have excellent defense partnerships. We work with different government agencies. We work with different defense primes, and we've been demonstrating our technology in much harder conditions, from a loss of calm all the way to the kinds of tasks that are being required. And we're parlaying those into industries like port management and port security, offshore data farms that are being constructed. And then my market adoption strategy in oil and gas is they're going to say, wow, we can't live without that. And now that you've got, some runtime under your belt, let's get some pilots in place. Let's try this out. And we're seeing that. And I've got a customer that I can't disclose right now, very large operator that has, we're setting up an entire task field, and they are going to evaluate the quality in which we're doing. So I think it's going to happen in time. I mean, it'll probably be on the geological time scale, but I've got a while. There's a much bigger ocean out there with things to do besides hydrocarbons, which is completely okay with me.
Yep.
Oil and gas is just a fraction of the market, it turns out. I mean, if you want to look at a total addressable market of doing work in the ocean, you're talking upwards of $30 billion. The oil and gas community is a fraction of that. I mean, if you consider everything from offshore wind, data farms, offshore data farms, subsea mining, aquaculture, telecommunications, ports, defense, it's much bigger than people actually realize, which is what we're excited about.
Absolutely. And I think that, you hit on a good point. There's been an increased emphasis in obviously data collection. And one of the things that we try and draw comparisons to on the show is that, despite the fact that for a lot of people, the offshore space and the ocean in general is sort of out of sight, out of mind. It may seem like this scary place, whether for operating or for, enjoying in your free time. We're very obviously intrinsically connected to it in many more ways than we think. Like the ocean is not only a place where we drill for offshore oil or install wind turbines, but 90% of everything, I think, is what they say is actually of goods that are delivered globally are transported and shipped via ocean freight. And there's communication cables that are crossing our oceans, and there's so much more to it. And so from your perspective, why would it be, to highlight sort of the importance of that, how would you best describe to someone who might not have any experience in the industry or really an understanding of how we're connected to the ocean, why what Houston Mechatronics is bringing to the table is important for our future, not only offshore, but also on land?
So I had one of my government customers had asked me just to give me write up my opinion on why we don't see as much innovation in the ocean space as we do space flight.
Yeah.
And because it's funny because on some levels the ocean is so much more accessible than space, but you see so much more. I don't know. It's like when anybody talks about space, they think just ultra high tech. and the ocean is this sort of really archaic place. So I wrote up this piece, but basically some of the tenets that I had pointed out were, just Google working in space and Google working in the ocean, right? And everything
Right.
starts with kids. How do we inspire a generation of kids to want to actually develop technology for the ocean? And well, very early on, if you just accept what you might Google as some of the, most common things that people talk about, you Google working in space and you see these awe-inspiring, existential landscapes of what could be out there, and it's just thought of like all these scientists and white lab coat folks are running around just doing something so beyond, what we could ever consider, because it's just so hard, right?
Yeah,
and it's inspiring. And then you Google working in the ocean and you see this rusted out ships and floppy hats and no teeth and these folks that are just miserable. They look miserable, right? Weathered and just the North Sea waves crashing over, and it just looks like the worst place anyone would ever want to put a career, right?
Yeah.
I mean, and so for me, I've always thought that we could make the ocean cool, right? Houston Mechatronics has a responsibility. HMI has a responsibility to bring some of that space flight awe factor and then turn it on its head and say, these problems are harder. They're harder than working in space. And isn't that cool? I mean, don't get me wrong. You have to expend a tremendous amount of energy to get to space. But once you're there, things are pretty chill. I mean, yes, there's vacuum, sure, but that's nothing like the weight of the ocean trying to crush you at, 4 miles under. And, the weight of the earth, right? The weight of the earth crushing you. And so it's like, and I get this question sometimes, what's harder, working in the ocean or working, designing a robot for the ocean or designing a robot for space? And I haven't decided whether it's 10 times harder or 50 times harder putting a robot in the ocean. And we have this feeling in our company that we literally have a responsibility to make it cool, to make, we do tons of educational outreach here. We do underwater robotics clubs in the middle schools here. We feel extremely partial to trying to educate an upcoming group of kids that the ocean is the single most important thing on planet Earth, related to how our health of a planet. And turns out we're sort of screwing it up. And we need to understand that better. And we need to create autonomous, semi-autonomous agents from the surface to the seabed to help fix it. And that's literally what the mission of this company is.
Yeah, I think that's awesome. I mean, I love to see that, because personally, as a fairly early career professional in the blue tech space, coming out of college and engineering school, there's very little emphasis or I guess accessibility to, at least in the past, careers in our industry that seem cool, just like you mentioned. I mean, there are some companies like Houston Mechatronics that are really changing that dynamic, but I think that in order for us to place, the importance on exploring the ocean, we need to think of, exploring the depths of the ocean as being just as cool, if not cooler, than landing an astronaut on Mars or the moon.
Here's a test. Name the first person on the moon.
Neil Armstrong.
Correct. Name the second person on the moon.
To be honest with you, I couldn't tell you.
Okay, cool. Well, all right. All right. So Neil Armstrong and Buzz Aldrin, right?
Buzz Aldrin, yeah.
Right. So number 1, number 2. I mean, obviously this is just standard reading, at NASA. So obviously,
yeah.
But still, you got number 1, right? You got number 1, Neil Armstrong. Name the first person to go to Challenger Deep.
Was it Victor Vescovo? He was the first one to go to all 5, right? I'm not sure.
Correct. You don't even know, right?
Okay.
So the point is, imagine you're in this space and you don't even know the dude, right? You don't even know the guy who went to Challenger Deep, the first person to go to the depths of the Marianas Trench. You don't even know.
Yeah. Right? No, you're right. You're right.
Exactly. Now imagine you're the general public.
Yeah. I mean,
They don't even know what the Marianas Trench is, let alone Challenger Deep in it.
Absolutely. Who was it? Let's hear it.
We're going to edit this out, okay?
Yeah, we'll edit this out.
So it's like, I think it's Don Walsh.
Okay.
Walsh was the last name.
Okay. Yeah.
So let's Google that. Hang on. Let's get to our computers.
Yeah. All right. We'll do that.
And you guys are totally going to edit this out. All right.
Yeah, of course we will. It's a really good point though, because, I think that even when we consider something that might be more mainstream, like in current day, we see how much emphasis is placed on, like, obviously the new Mars rover that recently landed versus sending a human in a manned submersible, Victor Vescovo, down to the deepest point, every single ocean on Earth. I mean, that's insane. But there's literally something the entire world knows about on the space side of things, and something that very, very few people know about in terms of exploring the ocean and actually sending explorers to, on like an absolutely insane mission. I mean, that's crazy.
Exactly.
So
Don Walsh, and Auguste Piccard.
Okay.
So Jacques Piccard, Auguste Piccard was his father, but Jacques Piccard and Don Walsh were the first two people to go to the depths of the lowest point on planet Earth. And it's just fascinating because no one knows that.
Yeah.
Right. And I can guarantee you, they don't even have any clue what the spacecraft was. Right.
Yeah.
The ocean craft, sorry, not the spacecraft, the ocean craft. So it's just fascinating to me because that just highlights the disparity. I mean, it's like everybody knows Neil Armstrong. The whole planet over, Neil Armstrong.
Yeah.
Nobody has a clue who Don Walsh is. Right. Yeah. And in fact, and to me, it's like, that guy was nuts.
It's crazy.
You get in this little submarine thing and you're going to go, okay. Yep. Anyway.
Yeah. No, I mean, it's a great point. And I think that, moving forward, in order for us to really build, a bubble around or I guess pop the bubble that is around the ocean space rather, and make it more accessible and make people realize that having a job at Houston Mechatronics is just as cool, if not cooler, than working at NASA or SpaceX is really important. And,
absolutely, that is one of our missions.
Yeah. And
in
your
opinion,
opinion,
to bring that cool factor to the ocean. And I'm telling you, the guys, edit that.
No, go ahead.
And I'm telling you, the folks that have come before us, who have been dropping dishwasher, refrigerator looking things off the side of a boat, leaking hydraulic fluid everywhere, trying to, I'm like, where's the tech, man? Where's the cool factor? Who are you going to inspire with that thing? Nobody. And what do you got now? You have a cost problem. You can't afford these vessel companies, these service companies. They're losing money hand over fist. These vessel companies are going out of business. Why? Because they have just continued to perpetuate something that is so ungodly expensive that now it's not, the cost model is not even a little broken. It's busted, and now it's like, what next? And so we've mortgaged all this technical debt for the last 40 years, and now we need to fix it, and that's what we're going to do.
Right. Yep. No, it's all really great points. And before I do want to get on to, some of the key points you've made surrounding autonomy. But before we do that, one other question regarding this space to subsea comparison that I'm sure you get all the time. What do you think? I mean, and this is a loaded question. I'll obviously frame it that way. But what do you think is more important, sending someone to Mars or mapping the entire ocean? I guess mapping the surface of Mars, which we probably already have done to some pretty high degree of accuracy, or mapping the remainder of our oceans, which I think are really only mapped to any decent resolution of about 5% in total.
Yeah, that's the figure I hear all the time, is that of the underwater community, we 95% of the landscape is still relatively uncharted. I mean, that's like asking a parent which of their two kids do they like better, right? I mean, I've been experienced in now both industries, I still have a passion for space flight. I'm highly critical of it sometimes. I mean, it's kind of like there's no worse critic on a smoker than an ex-smoker, right? So I do fall into that category sometimes. I'm like, oh, you're doing it wrong.
Right.
That's so stupid. But what you're speaking about is a bit more existential than that. Is it more important to seed life on another planet and get it and create another civilization to go up and running? I think Mr. Musk is on his way, and we can all cheer him on. I'm concerned about the planet we're already on.
Yeah.
And I think is it more important to have 100 people on Mars, or is it more important to ensure the sustained life for the next 7 to 8 billion people that are going to need to use this place? I sort of err on the latter, and I feel like we have some extremely critical issues that are barreling down the pipe right now. The overfishing of the oceans is tremendous. We're going to have a protein liquidity crunch coming up shortly with the overfishing of all of the seas. I mean, there's tons of documentaries on this, and it really opened my eyes how absolutely super critical things are right now in fishing in the ocean. And I mean, that's just one small detail that if not corrected is going to be a serious issue. We've got to get more into sustainable. Ocean harvesting, and technologies that we are working on directly relate to that. I mean, it's whether it's just doing the necessary surveys to understand the fish counts, if it's helping if it's helping monitor illegal fishing. I mean, you're going to have a deployed network of semi-autonomous agents that take low people to run, right? Like the cost of labor drives so much. So in order to actually deploy this tech, it has to be deployed in a way which de-emphasizes how many people it takes to use it. I mean, if you look at a standard ROV or even heck an AUV right now, an ROV takes 5 to 6 people to run, over a 24-hour period of time. It takes more. It'd be bad enough if it was just 1-to-1, right? One person to one RV, but it's actually 5-to-1. Why isn't it 1-to-50, right? I've never understood this.
Right. And
so we need to build in the amount of intelligence that allows one operator to control a fleet of things. And so we have to take much more of an air traffic controller management component to what's going on, and let the thing run on autopilot, and then intervene when we need to from time to time.
Right.
That is what we think is going to win the day.
Yeah. And so that's a great segue, I think, into, autonomy in general. And I think it's something that a lot of people are familiar with on land, obviously. The thought of getting in an Uber that drives you from point A to point B without a driver, who knows, when that realistically will be a thing. There's a lot of obstacles there, but how does that, challenge translate into the ocean? I mean, is building autonomy offshore just as difficult and something that is just as challenging? And how do you see yourself approaching that problem and solving it?
Well, this is one of these other fascinating problems that I don't understand why more people aren't just consumed by the difficulty.
Yeah.
So if you look at a lot of, I don't know, whether it's self-driving cars or some the way autonomy is developed on land right now, there's a lot of brute force methods where you just scour the internet for pictures that are contextually labeled. We're gonna train a robot to find a cat, right? That's pretty easy to do. There's billions of pictures of cats on the internet. They've been conveniently labeled by their owners, and especially even what Fluffy's doing, right? Here's Fluffy smacking a ball. Isn't he so cute? And so now you imagine you have all these crawling algorithms that just aggregate all these images. They know what they are because they're labeled, and you can train up your algorithms doing that. Well, guess what? There's not a lot of contextually labeled imagery of the ocean. And if there were, it wouldn't be that valid for that long. I mean, the fascinating part about the ocean is everything grows on everything, right? And so it poses it in a very challenging machine learning and autonomous manipulation problem, which is you don't have a lot of good training data. you're going to have to go into an environment and learn how to learn on the fly.
Right.
Why the hell isn't that just front and center and everybody's like thinking on how to build autonomous agents in the water? Is those sort of bedrock, extremely difficult machine learning and AI challenges fascinate us at HMI. And we have some of the world's leading experts in that area here. I think as evidenced by how well we're doing with the Defense Department. But we cannot wait to usher some of that technology into the commercial world, because it is truly going to be game changing. Going into an environment you've never seen before and actually being able to train on the fly, and you know, you have some seated imagery, but it's definitely not what you're looking for. Or it's what you're looking for doesn't look like what you trained on. So how do you understand that? And then how do you get the robot to understand what the robot's looking at? I mean, robot demos, a lot of people give robot demos crap sometimes because, you know, they're very slow and, you know, is the robot looking at that door handle, wondering if it's a door handle or a butterfly, right? But the challenges are just so tremendous that in order to have this truly ubiquitous deployment of these agents, these problems are going to have to be solved. And to me, they're much harder. It's much harder than some of the traditional space. I mean, self-driving's hard, right? And in fact, I don't think it's coming anytime soon. You know, what the example you just gave of you know, your Uber service picks you up, there's no one in the front seat, and you just get in and get whisked off to your destination 15 miles away through urban traffic. And then a mixture of rural, you know, jaunts of 2 or 3 kilometers. I don't know if that's ever coming. Within the next 10 to 15 years. And we have all the information you could ever want on how to make that work. We have the same challenges underwater, and we have such sparse data on how to tell the robots what to do.
Yeah. And so, okay, so I think this is a good time to kind of backtrack to the elevator pitch and then sort of reframe it, because what we talked about at the beginning here was that obviously your goal is to take the existing infrastructure for working offshore of, you know, ROVs and AUVs that require number of personnel, large topside vessels, a ton of money, ton of gas or diesel burning fuel, and then cut out a lot of that BS in the middle, reduce the costs, and be able to send multiple autonomous subsea and surface vehicles offshore that are controlled by semi-autonomous, that are controlled by like a land-based operations center. And so I saw the other day that you guys, there was a press release about the Hydronaut too. With the
Aquanaut's best friend.
Aquanaut's best friend. Yeah. So I guess it's Aquanaut's Uber to get offshore.
Exactly. Well, Forbes chronicled us a couple of years ago. They called us the Tesla of the subsurface. And although I didn't have any input into that article, I never would have called us that. I've sort of thought about it, and it is kind of right. I mean, we have a self-driving car with a humanoid robot on board. Right. We want to deploy a network of self-driving cars with humanoid robots on board that don't have to drive and walk. They just have to float and swim so the actual transportation, the mobility side of that's a bit easier. And then we trade off the actual manipulation, the dexterity part of it's a bit harder. But you know, that's good because we're experts in it.
Yeah. And so, you know, on that note of being sort of the Tesla of the subsea, and I guess that every project is probably going to be a little bit different in terms of requirements, but in your head, you know, having an operation station at shore, is it going to, you know, in the ideal world in the future, assuming all the technology falls into place, will Aquanaut swim from the shore out to the site and operate and maybe be resident subsea, or will you have with every Aquanaut a Hydronaut or an autonomous surface vehicle that actually takes it offshore and then deploys it? I mean, what's the ideal setup?
Depends on work scope. There are some of our ops cons for certain wind farm fields. It's completely doable to launch from shore and keep an Aquanaut on shore and send it out when you need to do things. But there's another important part that I'd like to bring up because I think it's extremely it's relevant, and especially highlighting some of the differences of the traditional. And so just to shelve your question for a second, then we'll come back to it.
Yeah, absolutely.
I feel like once we have a network of agents out there, these can be opportunistically subscribed to. So I don't think in the future the day rate point-to-point model is going to work. It takes an enormous amount of money to mobilize these ships out of port.
Yeah.
That's actually overlooked. I mean, everybody likes to talk about the $80,000, $60,000 a day rate on the vessel, and then the $5,000 to $8,000 a day rate on the ROV. But they also forget the $500,000 it actually takes to get the boat mobilized and sent out. Right? We just sort of forget that cost, and then when we send it back home, we forget that cost. We also forget the cost of what it truly takes to put all the people on it and give them spaghetti to eat and have it delayed with weather and all sorts of stuff. And I'm tired of the field billing the operators how you do the job. I think you can bill the operators what job you're doing. I think we can abstract away how we did it, right? So I feel that there's going to be a day that once you get the technology in place, that you will find that there's this network effect that takes over. And they're like, wow, there's an Aquanaut 12 kilometers away. I'm just going to call it up on my iPad on the drill floor because I need this work done. And once you can call an Aquanaut in like an Uber and have something done, you can opportunistically subscribe to its service, and then you can release it when you're done with it. And then my job as a company will be, how do I attach the users to the device? So my job becomes, how do I stack up the utilization rate as high as possible for the device? And I think you can blend customers. I think, it's not done now, right? ROVs typically have a very low utilization rate because they're kind of contracted to one customer for a very long time. And sometimes that customer's not doing anything with it. I think that's a terrible use of capital hardware. So I feel like you can stack customers and opportunistically use it for somebody else in the downtime. Well, you need a physical morphology that would let you do that. No one thinks about doing that because you can't do that today. An ROV is tethered with an umbilical to a platform or a ship, and it's kind of a hot mess to try to get it to work for somebody else when it's working for another person.
Right. Okay, so very cool. I mean, that's I think it's a really great comparison for people to kind of understand in the way that you could essentially call an Aquanaut as if it's an Uber, sometime in the future if you need work done offshore, which is very, very interesting thought. And so on some of those notes that we mentioned, with cutting out some of the in-between infrastructure and costs and number of personnel who have to go offshore, there's obviously a push for reducing all of those things, and including greenhouse gas emissions. And so just to kind of frame this as more of a market-based question, there's obviously a lot of people who work offshore right now, and no different than what we're seeing is autonomy changing the workforce on land. It will inevitably change the workforce offshore, and jobs will be created onshore to control some of those assets. How do you respond to some of the people who may meet that with skepticism? And do you think that, in the future, the jobs that are created onshore will still require some of those like technical offshore skills that a lot of people rely on today?
I would say if you look at the historical data, technology has always been a job creator. It's deflationary for price, but it's usually a job creator. Now, jobs move. There's mobility within the job market. Some jobs do go away, but other jobs are created. There's a lot of historical evidence for it. There's tons of articles written about it. Just think about what the recording industry did for music when the piano was the only thing in the house, right? So, turn of the century, or I guess turn of the century, 1900s, the piano was like the main focus of where kind of music in the home. And piano manufacturing, I think during that time was one of the largest, if not the largest, manufacturing things in the country. And well, turns out when the advent of the radio and then the recording industry kicked up, we didn't really manufacture many pianos anymore, right? So there are some piano manufacturers lost their jobs, without a doubt.
Right.
But how many more jobs were created by the recording industry? So I think you have to look at the aggregate, and that's what's most important. And over time, technology has an influence, which usually creates jobs. And I used to joke with people, especially at NASA a long time ago. We had two modes of running the robot. We had a direct teleoperation mode, and we had autonomous mode. And our flagship robot back at NASA was Robonaut. And it took 2 people to teleoperate Robonaut. It took 8 people to run it autonomously. So I was like, I don't know. I don't think you understand autonomy quite right if you think jobs are going away. Right. I think coronavirus has shown us that we can't be too over reliant on a heavy personnel infrastructure. And I think it taught us something about supply chains. I also think it taught us about where automation might be best served. And we should look more into that. And so I don't promote Aquanaut as a job taker. That's not what we're about. Yeah. It's that the only technology we have to use right now requires a bunch of people. And we should think about the day when that's not the case. What are those people going to do? I mean, one of the most unsung, I think, machines taking jobs was the ATM machine in the 70s. You know, you didn't have to go to the bank. You used to have to go to the bank to get cash. Then all of a sudden the ATM machine came out on the market, and you just had to go to a computer to get cash. And it is true that some bank tellers lost their jobs. But it turns out when the bank teller didn't have to focus on doing money changing, the bank were able to pull those bank tellers into more value-added positions like loan processing. And so bank tellers per location went down, but banks opened more locations because of the profitability of the bank. And if you look at the employment rate of the bank teller since 2000, it's outpaced the national average of employment. So, I mean, I think those are some clear examples of where technology comes in, infuses itself into the employment marketplace, and we actually create jobs, even in the same industry.
Yeah. And I mean, you guys are doing just that, right? I mean, you're growing aggressively right now, as far as I can tell, and starting to expand to have more of a global footprint. So for you guys, I mean, what does the next year look like? I mean, how do you plan to grow and create more jobs in the space? And obviously, as you work through maybe more of the design phases and final design phases at the moment, and then transition into more of an operational model, what does the future hold for you guys from, an employment front and a reinvestment front?
Well, we've got amazing investors now. They understand the patience of the offshore industry. They've deployed patient capital to us. We know these changes aren't coming overnight.
Yeah.
We also know that when we actually, we stack our go-to-market strategy with customers that have an appetite for, hey, that didn't work, try it again, all the way to people that are unforgiving if you screw up. Naturally, the unforgiving if you screw ups are at the end, and hey, that was cool, try it again are at the beginning. And so we have this very methodical go-to-market strategy, which is over a matter of years, right? I mean, we're not trying to alter an entire landscape and an industry overnight. We know that this is a long play, but anything worth doing is going to be kind of complicated and hard to pull off. So we have the right investors. We are looking for further investment. It is not cheap to deploy technology in the ocean, which is, getting back to one of our earlier points, is why I think it's been so uninnovated in for a long time. But we just went into that problem eyes wide open, and we made sure we had enough cash to pull it off, or we had people that could give us more cash that we need. These are seminal problems, foundational problems to the planet. And I think we have people that want to see us succeed.
Very cool. And so one of the comments that you made earlier with regard to autonomy was that obviously the thought of having, autonomy in our daily lives from the perspective, at least of it, like a self-driving Uber picking you up and taking you like a mile or two down the road is likely further out than a lot of people might hope. But in your eyes, for, the next 5 years or 10 years of the offshore space and the ocean space, what do you think is a realistic target for when a hydronaut will have an aquanaut, strapped on the deck of the vessel, transit with supervised autonomy offshore, and be able to deploy and recover aquanaut after completing an untethered autonomous mission? What do you think? Like, realistically, what's that scope look like?
Speaking of autonomy in our lives, so you were in Boston recently, but now you're in Colorado. How did you get there? You took a plane?
I actually drove this time. I did not.
Oh, you just destroyed my entire idea. All right. Well, most people would have flown.
Well, let's say that I flew. Let's say that I flew.
How much do you think that pilot was controlling the airplane the entire time? Not much, right?
Very, very minimal. They're not. Maybe
those things fly on. They fly on.
Maybe some controls and.
That's right. So most people experience autonomy quite often, especially when they're on airplanes. So flying a hydronaut is much more like flying an airplane. Autonomous surface vessel tech is fairly understood, and you don't have to deal with too much with pedestrians and dogs running out and balls bouncing into the street. So we are partnered with very good people that understand the navigational autonomy. Our specialty is much more on the cooperation of the two robots and the manipulation side. So when is that going to get deployed? We have agreements in place with partners to get that into the ocean within the next 12 months. So we are working through that process right now. But this isn't like 5 years from now. This is mid 2020. This is summer of 2022, and we like to lean forward. It's just the nature of who we are. We like to get out there and show people what's possible, and then we back it up with actual execution. But this isn't 10 years away.
Yeah. Very cool. It's interesting to draw the comparison between, what we see in more of the mainstream, I guess, in your daily lives with how autonomy will impact us or already is, versus a space like the ocean where, again, so much of it is out of sight, out of mind.
Yep.
And so as we kind of approach the top of the hour here, one of my questions as obviously a tech entrepreneur in the space and someone who's really approached problems differently compared to maybe the traditional refrigerators and dishwasher machines that we see thrown off the side of boats with thrusters on them. What have been the biggest challenges that you've faced in the last 6 years of leading HMI from both a business perspective and a technical perspective?
Oh man.
It doesn't have to be limited to one either. I'm sure there are many.
I know. It's like, I think next time I'm going to just write a dating app. I think that would probably, my wife tells me all the time, you have picked the absolute hardest thing to do on planet Earth to try to build a business around. But honestly, that's kind of the fascination. I'm a hard tech guy. Like I said, I love the blend of robot intelligence and robots. Pure autonomy for autonomy's sake. Maybe having just a financial program that knows how to trade because it's so smart. It doesn't interest me. It just never has. I like to see the physical instantiation of something as it interacts in the world. So the challenges along the way of trying to implement something like that are plentiful if you were doing it on land. In the ocean, it's exponentially hard. And it's the cost to iterate something, the cost of the raw materials. We've tried to do things very differently. The entire robot the first robot we made was pure composite. Now now that we're in production of multiple units, we've got a much more blended substructure that's more aluminum, and then it's aluminum subframe and then overlaid with different composite material. But honestly, the hardest part has been the lack of investment in the ocean. I mean, frankly speaking, so the entire investment community is biased towards apps to begin with, right? So if you look at 2019 numbers, there were $167 billion deployed in venture capital. 60% of that went to software.
Wow.
The other 32% went to fintech, healthcare, consumer facing, biotech. 8% of it went to industrial technology. 8%. Of that industrial technology, how much of it do you think was industrial technology for the marine space? A lot less than that.
I would guess less than 1%.
Correct. So of a potential $167 billion, I'm looking at less than $1 billion of available capital worldwide to invest in this space.
Wow.
Think about that.
That's amazing, because I mean, you think about all the stuff that we need to do.
Correct. It's depressing, actually.
I mean, yeah, that's wild. Do you think that precedent will change? Do you think that more? Have you seen, I guess, in the last few years that there's more capital being brought to the space?
Absolutely.
Okay.
Lots of ocean tech companies are starting, and I don't want to promote a bunch of my competitors, but there's a lot of autonomous surface vessel companies that have kicked up recently. There's a lot of autonomous, I don't know what to call them, but there's a lot more robotics going into the ocean now. I mean, some of the famous ones: liquid robotics, sail drone. You've got you got Ocean Infinity, which is really been promoting their Armada fleet, which is a variation on what we're doing. They still have this umbilical problem that I think they're going to be challenged with. There's more interest, right? But still, though, your tried and true venture capital investment is not coming in force yet, which I still find ironic, considering the importance of what the ocean represents to the earth.
Yeah, absolutely. And so I know you're really busy and need to get back to changing the way that we operate in the ocean. But I think one of the things that has resonated most with me throughout our conversation is really the focus on education and making the ocean cool again. And in order to really attract talent to the space, and if we want to change it and bring more attention to it, that's really a huge focal point moving forward. What would your sort of parting message be to, kids or early career professionals, or, people who are in engineering school or looking to start a company? What's your message as to why they should look at the blue economy, in the future?
Because I think there's a handful of really well-known space companies, SpaceX and Blue Origin and your traditional space like Boeing's and Lockheed's and obviously NASA. We haven't even uncovered what the top 10 new ocean tech companies are going to be. And if you really wanted to get into something unique and usher in a new wave, no pun intended, the ocean space is one of the most exciting places that you can uncover more challenges than you know what to do with, more engineering problems, more societal relevance than any other place I can think of.
Great way to end it. And for anyone who wants to follow along, and we'll link to everything in the show notes when this episode gets released, where can people follow along with what you guys have going on, the latest updates, and maybe see in the next year Hydronaut deploying Aquanaut? Yeah.
Always check out our website. Our LinkedIn's always popping with something fun. www.houstonmechatronics.com, and then look us up on LinkedIn. You can follow me on LinkedIn. I'm always, even though it's like a personal LinkedIn account, it's always like it's a surrogate HMI account practically.
Sure.
But we're pretty good about staying in the news, so it won't be too hard to follow along.
Cool. Great. Well, Nick, thank you so much for joining today. It was an awesome conversation. I look forward to hopefully doing it again soon.
Yeah. Love it. Thank you very much. And just tremendous discussion. Thank you.
If you are interested in learning more about Houston Mechatronics and their mission to change the way we interact with the ocean and the blue economy, we suggest you check out their website at houstonmechatronics.com, linked in the description for this podcast. We hope you enjoyed this episode of The Other 70% with Nortech. As always, we are looking for new ways to bring together those with an interest in our blue planet. Tune in again in 2 weeks to hear more from inspiring entrepreneurs, technologists, and activists who are building the blue vision for the future.